Hey there. Forget about juggling multiple cloud services. Did you know that 8 out of 10 DevOps engineers struggle with multi-cloud management? Don't be one of them. Stick with me for the next 10 minutes. First, I've got a killer animation that breaks down what Crossplane is all about. Then we're rolling up our sleeves with an exciting demo. It's going to be a total eye-opener. And trust me, you don't want to miss the end. Spoiler alert, it has to do with drift detection. Ready to own the cloud game? Let's dive in. In this video, we will learn about Crossplane, which is a Kubernetes native infrastructure management tool. The world of cloud computing is vast, intricate, and ever-evolving. Companies are continually exploring new ways to simplify infrastructure management and enhance application deployment across multiple cloud providers. One such solution gaining prominence is Crossplane.io. Developed as an open source project, Crossplane allows organizations to manage and provision infrastructure directly from Kubernetes. This video aims to serve as a comprehensive introduction to Crossplane, its features, use cases, how to get started with it, and even a comparison with Terraform. So what is Crossplane? Crossplane is a Kubernetes add-on that extends the Kubernetes API to manage and provision cloud infrastructure, services, and other resources. It takes the declarative API-driven approach of Kubernetes and applies it to infrastructure management, turning Kubernetes into a universal control plane. Crossplane is a tool that, number one, provides declarative configuration. Just like Kubernetes, you declare the desired state and Crossplane takes care of the rest. Number two, it enables multi-cloud deployments. So deploy applications and resources across AWS, Azure, GCP, and other cloud providers seamlessly. And number three, offers infrastructure as code. Keep track of your infrastructure configuration in the form of code to enable version control, sharing, and reusability. Let's now take a look at some of its core features. First up is provider packages. Crossplane supports a wide range of cloud providers and technologies known as providers. These packages define the necessary CRDs, which is custom resource definitions, for each cloud resource and therefore extending the Kubernetes API. The next feature is composition. Crossplane's composition feature allows you to define abstract resources known as XRDs, or composite resource definitions, which can then be mapped to one or more concrete resources in the underlying providers. Our next feature is resource claim. Resource claims provide an abstract and provider-agnostic way for applications to request resources. For example, instead of requesting an AWS RDS database, you can request a generic SQL database and let Crossplane decide which provider to use based on predefined policies or composition. The final feature we'll talk about is policy-driven resource allocation. Crossplane enables organizations to set policies that determine how resources are provisioned. This is especially useful in multi-cloud or multi-namespace Kubernetes clusters. It's relatively easy to get started with Crossplane. Installing Crossplane involves running a few simple commands. You should have kubectl installed and configured before starting the installation. On the screen for you, you can see the installation instructions. Let's take a look at a simple example that we're going to use for our demo at the end of this video. We're going to provision an S3 bucket on AWS using Crossplane. First thing we need to do is install the AWS provider. Then we're going to need to configure the provider credentials, followed by creating provider configuration, which will provision S3 bucket, and then we can check the resource status. Now you might be thinking, I already use Terraform. Why bother with Crossplane? What advantages does Crossplane give me over Terraform? Let's now take a look at a comparison between the two. Both Crossplane and Terraform are powerful tools for infrastructure management, but they differ in philosophy, architecture, and capabilities. While Terraform has been a popular choice for infrastructure as code, Crossplane offers unique benefits, especially for organizations that are heavily invested in Kubernetes. Let's now take a look at some of the key advantages of using Crossplane over Terraform. The first advantage is that it is Kubernetes native. Crossplane extends the Kubernetes API, making it a Kubernetes native solution. This offers a unified way to manage both your applications and infrastructure using Kubernetes declarative API. If your organization is already using Kubernetes, adopting Crossplane can simplify your tech stack and reduce context switching. The second advantage is real-time resource status. Crossplane integrates seamlessly with Kubernetes control loop, enabling real-time monitoring and automated healing capabilities. Terraform needs separate tooling to achieve something similar, as it does not natively provide real-time state management. So Crossplane solves the problem of drift detection and correction. The third advantage is dynamic provisioning. Crossplane allows dynamic provisioning of resources using resource claims and compositions. For example, an application developer can simply ask for a database without worrying about the underlying cloud provider, version, or configuration details. Policies and compositions defined by the infrastructure team handle those specifics. The fourth advantage is multi-cloud deployments. Both Terraform and Crossplane support multi-cloud deployments, but Crossplane offers a more unified, API-centric approach. You can create abstract resources that map to different cloud services, allowing developers to deploy resources without worrying about vendor-specific configurations. Advantage number 5 is policy-based governance. With Crossplane, you can set granular policies for resource provisioning, ensuring that resources comply with organizational policies and best practices. While Terraform also allows for some governance, using modules and variable validation, Crossplane's Kubernetes native approach enables more dynamic and real-time policy enforcement. The sixth advantage is CI/CD integration. Since Crossplane leverages the Kubernetes API, it fits naturally into Kubernetes native CI/CD pipelines. With Terraform, CI/CD integration is possible, but usually requires third-party plugins or specialized scripts. Advantage number 7 is team collaboration. Crossplane allows you to define roles and responsibilities more naturally by using existing Kubernetes RBAC. Developers, operators, and infrastructure teams can collaborate more efficiently, each interacting with the cluster according to their permissions and needs. The eighth advantage is no state files to manage. Terraform uses state files to keep track of resources, which can become a point of failure if not managed carefully. Crossplane, being a Kubernetes add-on, relies on Kubernetes etcd for state management, eliminating the need for separate state files and having to secure your state file. Advantage number 9, and our final one, is extensibility. Crossplane can be easily extended to support custom resources or in-house tooling, while Terraform also offers extensibility via custom providers. Doing this in a Kubernetes native way may be more straightforward if you already operate in a Kubernetes ecosystem. But then what are some drawbacks of Crossplane? First is maturity and ecosystem. Terraform has been around longer and has a vast ecosystem of providers for almost every service or platform you can think of. Crossplane is comparatively newer, and while growing rapidly, doesn't yet have the breadth of integrations that Terraform has. Secondly, learning curve for non-Kubernetes users. If you're not already immersed in the Kubernetes world, Crossplane can be a bit more challenging to pick up. On the other hand, Terraform is a standalone tool that doesn't require Kubernetes knowledge. Our third and final point is complexity. Adding the Kubernetes layer can introduce complexity in terms of setup, maintenance, and understanding. For those who just want to define and provision infrastructure without dealing with Kubernetes, Terraform might be more straightforward. In conclusion, while both Terraform and Crossplane are excellent tools for infrastructure management, Crossplane offers particular advantages for Kubernetes native organizations. From real-time resource status, dynamic provisioning, and policy-based governance, to seamless CI/CD integration and extensibility, Crossplane offers a compelling case for those looking to streamline their infrastructure management processes. And now, let's take a look at a demo of Crossplane. All right, now let's take a look at our demo. I'm here in my Visual Studio Code, and I have a Kubernetes cluster that is running already on my machine, and it is using Docker Desktop on WSL in my Windows environment. All right, so if I want to show you here my namespaces, I have just the basic namespaces, and we're going to start off by installing Crossplane. So we're going to add our repo here, the Crossplane Helm repo, and then we're going to install it. And this is going to get installed in a namespace called Crossplane System. So if I look at my namespaces, I see it there, and I change my namespace to the Crossplane namespace. All right, let's make sure our pods are up and running. So let's run this command. Okay, everything looks good. I can run get all just to show you everything in this namespace here that's running. We can also see the API endpoints with our kubectl API resources, and we're going to grep for Crossplane. And you can see some of our CRDs here. Make this a bit bigger. You can see the composite resource definitions, XRDs, compositions, and provider revisions, providers, and so on. Now what we want to do is create a Kubernetes secret for AWS, and I have a file here, sample file. I have my actual file here that I'm not pushing into Git. So what you want to do is update this file, change the name to aws-credentials.txt as you see here, and just add your AWS access key ID and AWS secret access key right here. And then from that, we can generate a secret in Kubernetes. So the way this will work is that we can create the secret using this command. Let's clear here, run this, and this should create a secret. If we run kubectl get secret, you should see it show up here, AWS secret. Okay, we can also describe the secret to show you more details. The data here is under this key called creds. All right, now let's get our AWS provider and provider config ready. So what we're going to do is we're going to use this provider.yaml file. And in this provider.yaml file, you can see that we have, we're calling the API version package Crossplane IO version 1. And this is of kind provider. Remember, Crossplane creates a bunch of CRDs. So this provider, this kind is provider. We're giving it a name, provider AWS S3. And we're using the package from Upbound. And we're using the latest version here, version 42.0. And I can quickly show you the documentation, how to be able to grab this provider from Upbound. And then we're creating a provider config. This is where we're going to reference our secret, the AWS secret. So this allows Crossplane to go out to AWS and provision our S3 bucket that we're going to provision. All right, so let's go ahead and apply our provider.yaml. All right, and I think we have an error here. Yeah, we got to run this again. So what happens is I actually should split this up, and I'll probably do that later. Instead of putting both the provider and the provider config in one place, I need to separate them, because what I see is that the provider config relies on the provider to be deployed first. And when we try to deploy both of them at the same time, what I see is that I think the provider config goes first before the provider, and that's why it errors out. So we just need to split these into two separate files. And now let's go ahead and create our S3 bucket. And to create our S3 bucket, we have this s3bucket.yaml. So if we take a look at it here, you can see that we have a kind bucket and the kind bucket ownership controls that I've added in here. And it's pretty straightforward. We're deploying this in US East 1, and we have a tag foobar. And then we have a bucket selector that basically ties the bucket ownership controls to this particular bucket. So if you're familiar with Terraform, it's kind of like referencing one resource within another resource. And you can see here the match labels, testing outbound example name S3 matches the label I gave for my bucket at the top. The region is still US East 1, and then we have a rule ownership, object ownership is bucket owner preferred. All right, so let's go ahead and deploy this. Run kubectl apply and apply our S3 bucket, and we can check and see kubectl get bucket. So this is a new CRD. It's not ready yet. Here's a bucket Tekken8 Crossplane is the name that I gave it. So we can wait just a little bit. Now it's ready. So let's go ahead and check our AWS console, and let's refresh it. As you can see, there's nothing here. Let's refresh, and here we go. Tekken8 Crossplane is the bucket that we created. You can see the properties. Crossplane puts a bunch of tags in here, but here's the tag we put, foobar, as we saw before. And from a permissions perspective, under the object ownership, you can see that the bucket owner preferred is created here for us. So very simple example to get us going. And what I want to show you now is the drift detection that I promised you in the beginning of this video. So here what we're going to do is go back to our buckets, and I'm going to delete this bucket outside of Crossplane. So if I go ahead and write Tekken8 Crossplane and delete bucket, now I have no buckets, so let's double check. There is no bucket here. All right. And now if I go back to my Visual Studio Code, what will happen is we want to run this command. First kubectl get bucket. It still shows up here, but it takes a little bit of time for this to reconcile. Okay, so what's going to happen, and we're going to have to wait maybe 5 minutes or so. In the meantime, I'll show you a few of the documentation around Upbound. But unlike Terraform, for example, what's happening here is that we're relying on Kubernetes reconciliation loop. So if you recall, if you try to delete a pod within Kubernetes, if that pod is part of a deployment, the deployment will go back and recreate that pod for us, because that's the declared state that we told Kubernetes to create for us. So in the same way, since we've created this bucket, we've told Kubernetes, hey, this bucket needs to be there. And if somebody tries to delete it outside of Kubernetes here, then the Kubernetes control loop is going to go back and recreate it for us. All right. Okay. So while we wait for this, let me show you a little bit how I created this S3 bucket very simply by following the documentation. All right. So you want to go and look for Upbound Marketplace, and that's where we're going to find all the providers we need. And in here, we're interested in AWS. So I can look up AWS S3, and from here we can take a closer look. We have a bunch of matches. It somehow doesn't see our AWS S3. Let's try this again. There we go. So provider AWS S3 is what we're looking for. And Upbound recently broke down the provider AWS into a family of providers that that have been spread out, meaning that you can see here, this is a monolithic AWS provider that had 916 managed resources, and it was slowing down the Kubernetes control plane that we're using. So what Upbound decided to do is to break out these into multiple providers. So provider AWS S3, for example, if we go in here, it only has 23 managed resources, so it doesn't bog down the Kubernetes control plane. So from here, I want to create a bucket resource. So I can go down here, look for bucket. And from here, I can say, all right, what's the API schema for me? And you can see here that I have really what you'll be looking for the most part is under for provider. You can see it's asking for a region, and this is a required parameter. And then tags. You can add some tags here. And I always jump to the examples, right? Take a quick example here. You can grab this and update it as necessary, right? So that's what gave me this portion here, right? My bucket. But now I need a bucket ownership controls. So to get that, I need to go back and go back here. And by the way, when you're in the provider here, you can install the manifest like this. If you click this button, it's going to give you the provider, and you just copy it. And this is the manifest that I used back here in the provider. You can see this is the provider I needed. So I just copied it right here. And then the provider config, of course, you'll have that in a separate file. Okay, so the next thing is we needed the bucket ownership controls. So how do we get that? And the bucket ownership controls, we would just look for it here. So if I look up ownership, it shows up right here. And once again, I can take a look at the API reference under for provider. You can see a bucket, name of the bucket that you want to associate the access point with. So this is how we reference the other bucket. And then the name, of course, for bucket ref, and so on. But first thing I do is jump to an example, right? And I copy that example, and you can see here the bucket selector that will grab the match label and correspond this to my other S3 bucket resource. So you copy that, and once again, we can throw it in here, and this is how we've created our bucket. So this is a pretty straightforward way of provisioning. Now, as you'll see in future videos, as I go through Crossplane, there is a lot more that Crossplane offers. And there's a separation between a developer role and a platform engineer role or a DevOps engineer role, so that you can generate custom resources, if you will. Think of those as modules in Terraform. These are called XRs or composite resources. And from there, you can really abstract anything. So you can abstract a bucket across GCP, AWS, and Azure. You can abstract a database, a SQL database across these three clouds. And then there's something called a claim. So the developer will create a claim that will enable them to create a database wherever, right? Wherever the platform engineer decides to create that composite and composite resource definition. These terms are going to be discussed in future videos, so don't worry too much about them. The whole point is that I want to show you how flexible that Crossplane can get, enabling a true internal developer platform that works for platform engineering teams. All right, let's jump back here and see if we've actually been able to recreate our S3 bucket. So let's see here. Let's refresh. And so far it hasn't been created. It takes about 5 minutes, I think, last time I checked. So let's pause the video and I'll come back and show you that it has reconciled by itself. All right, I just refreshed and here it is. And you can see the creation date, 1442. Right now it's 1444, so about 2 minutes ago. So if you go back in the video, you can probably calculate how long this took. So if I go back and take a look at our kubectl commands, you can see when I run it, normal created external resource 2 minutes ago. There you go. So it took maybe 12 minutes, maybe 10 minutes, somewhere around there. But yeah, that's drift detection and correction for you with Crossplane, which is something that Terraform has struggled with, and it needed some external help, whether you're running with Terraform Cloud or some other mechanism. Env0 has that as well, or you can do drift detection. But with Kubernetes here, it also does the correction for you, so that folks are not tempted to do things outside of the management of the infrastructure as code platform, such as Crossplane. And that way, if you need to make changes, you need to make changes directly through Crossplane itself. Well, hopefully this has been helpful as an introduction to Crossplane and what it is all about, and some of the differences between Crossplane and Terraform. And we saw also a demo here with drift detection and correction. And stick around for future videos where I dig a little bit deeper into Crossplane and some of the abstractions and concepts that it has.